Just before I uploaded this video to YouTube, I got an email from the sales manager at DCC Concepts in the UK. And he tells me that apparently as a result of this interim deal between the US and the UK on tariffs, they are not charging the 30% made in China tariff on their products. So that means only the 10% tariff for UK products will be charged for their products that you purchase from their website or possibly from Rails of Sheffield or some other source in the UK that would be shipped to the US. Also, as far as I know, the de minimis rule is still in effect with the UK, and that means that anything that you ship into the US under $800 for hobby uses will not be subject to any tariff at all. So for right now, we have a very narrow window of opportunity. It extends until August the 12th, and at that point, we don't know what's going to happen because that's the end of this 90-day interim agreement. But for right now, no 30% tariff on Chinese-made products that come through the UK, and potentially nothing as far as the 10% tariff on the UK, according to the de minimis rule. So, for right now, if you've got something that you want to get that DCC Concepts makes, it would be a great time to do that. But first, check with Ryan Matthews at ironplanethobbies.com and see if they have the product in stock, because it still might be cheaper to purchase directly from them instead of getting it from the UK. So that's my news flash. Let's move on and start the video. Hi, I'm Larry Puckett. Well, today we've got two things I want to accomplish. First off, I want to install the DCC power bus under the layout so we can actually begin connecting the track feeders to it. And I'm also going to begin installing switch machines. Now, these are DCC Concepts IP digital switch machines. I've used them in the past, and I did a full video on these. So I will refer you back to that, and I'll put a link to it above me here so you can go back and watch it, because I'm not going to go into a lot of the details about these. I'm just going to show you how to install them and set them up, and then we'll move on from there. So let's go ahead, roll the intro, and we'll get started. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. Now, before we do get started with the power bus and the switch machines, I do want to address a couple of comments from last week's video. And several people took umbrage with the fact that I pronounce the word solder, solder. Now, if you will simply look up on the internet the word solder, you will find that in North America it is pronounced as if it is spelled S-O-D-D-E-R, solder. And that's the way we pronounce it, and it's not going to change. So get used to me calling it solder. Now, another thing. Somebody made a comment about cleaning the rails. And yes, it can be a good idea to clean your rails before you solder them. Now, I didn't feel I needed to do that because I was working with all new products. The rails were nice and clean and shiny. However, some of the older stuff that you'll run into will have oxidation on it and maybe some residue left over from previous use. And there's a couple of easy ways that you can take care of that. As far as cleaning oxidation off, one thing you can use is this little brush right here. And I got this from Micromark a number of years ago, and it works very well. It's like a mechanical pencil. You turn this black knob here, and the wire brush can be extended out or retracted a bit. And that works great. You can just take it and clean the side of the rails like this. It's easy to control. And this brass tip here screws off, and you can get replacements for these brushes once they've been worn a lot. And as I said, I got this from Micromark. DCC Concepts in the UK also sells one that's almost identical to it. And you can get refills for these brushes, and they come in either brass or steel or fiberglass. And I prefer the brass ones. Sometimes for really tough buildup, I will use the steel ones. I don't like using the fiberglass because you end up with little pieces of fiberglass embedded in your fingertips too often. So I threw those away right away. Now I've also seen people use a rotary tool with a wire brush on it. And that is a very aggressive way to go about it. It does work, but you have to be very careful when you get around your plastic ties because it will strip off the spikes in no time at all. So I tend to stay away from using this. If you have old rail or old turnouts that have solder on them, you can easily get that off just by applying heat with your soldering iron to the end of the rail that is covered with solder, and you can remove that with your soldering iron and scrape it off on a cleaning pad, or you can use this little thing here. It's called a flex wick. Now this is the flex wick right here, and you can see it's just a flexible piece of braided copper wire, and that's all it is. So all you would need to do is place that against excess solder on your rails, hit it with the tip of a soldering iron, just enough to melt that excess solder, and it will be taken up in this braid, okay? It will wick it up just like cotton wicks up water. Very easy to use. Like I said, this one is called Flex Wick. Just look up desoldering wicks or desoldering braid, any of that kind of thing on Amazon or at any of the places that sell solder and electronic supplies. Also, one thing you can do is just take and place the tip of your soldering iron against the web of the rail where you have the excess solder, and it will heat up, liquefy, and tend to flow down by capillary action into that rail joiner down there. And that will remove a lot of the excess solder. Now, one other thing, I had promised to look up and find out where I got these little rubber caps for use for sealing caulk cartridges in between usages. And so I finally found those, and I'm going to show you right here on the screen what those are, and you can just do a quick screen capture and then save that for later. Look that up and order it yourself. Once again, great for sealing these. Since I started using these, I haven't had to throw away any caulk cartridges because they dried up on me. One other question that came up concerned liquid nails. One of the things I saw in the instructions said that liquid nails is not designed for use with foam-to-foam contact. So they meant foam board to foam board in construction settings. For our uses, it's not quite as straightforward as that, even though this is foam to foam. So what I wanted to do was to find out, under foam to foam, how long does it take this stuff to dry? And how tightly bound is it in the meantime? So I cut 4 pieces of foam, and I applied patches of the liquid nails. Right there you can see it dried. And I applied that to all 4 of these pieces, as you can see here. Then I waited 1 day, 3 days, 5 days, and 7 days. And why 7 days? Because they say that it takes up to a week for liquid nails to completely set up. So I wanted to find out how that was going to work. So after 1 day, I pulled this up, and sure enough, it was dry around the edges, but it was still tacky on the inside. After 3 days, more of the periphery was dry and set up, but there was still some tackiness in the center. After 5 days, it was almost all completely set up, with again, just a fine line down the center still tacky and moist. And finally, after 7 days, it was completely set up. So, in the meantime, these things were very tightly held in place. I haven't had any problem at all here on the layout. It hasn't come loose, moved, or anything. So my take from all of this is that these construction adhesives work fine. You just have to be aware of the fact that it does take, as they say, up to 7 days for the adhesive to completely set up. In the meantime, it's not going to be a problem for you. And I talked to the folks at Walthers, and they have been using adhesive caulk, and they've also tried what they call white glue. Now, I assume what they meant was white PVA type glue, like Elmer's or some of the others of that ilk. So they've been very happy with using that as well. So I think what we've got here is a situation where these adhesives are going to work great, but just remember that those adhesives are designed firstly for construction purposes, and the instructions are written under that scenario. Okay, let's go ahead and get started with working on the DCC power bus. Okay, I'm over here on this side. One of the great things about modules is they're easy. You can pop them up on a sawhorse and work on them very conveniently instead of having to crawl around underneath to do all of your wiring and maintenance and things like that. Okay, so the first thing I've got to do before we can install our bus here is I've got to drill holes to run the wires through because it has to go through these ends and the center supports. So that's going to be the first thing I'm going to do. So let me bring you in closer and you can watch as I drill holes. Now as you can see, I've marked a center line right here and I'm going to drill 2 holes. One here for the power bus and another one down here for the accessory bus, because that's one of the things I'm going to be installing here is both a power bus and an accessory bus, and we'll go in more detail on that when we start installing the DCC system. So what I've got is, this is a 19 millimeter drill bit here, and that's left over from the DCC Concepts alignment dowel installation. So I'm just going to punch the hole right here and make a little noise in sawdust. Now this is what I'm going to be using for the connections between the modules. And these are called Anderson power poles. And that's why I need that fairly large diameter 19 millimeter bit to make a hole. And these are a very low resistance connector. So they're great for modules like this. They're available in different amperages. I just used the 15 amp version, which is this right here. And they come in a kit, basically. You get the little red and black connectors, and they come in different colors. And then they also have little metal inserts that you have to connect to the end of your wire and insert them in here. But when you're done, you've got something, it's color-coded, and it will only go together one way. So they're basically polarized in that to that extent, so you don't end up putting together mismatched power buses. And I'm going to use those for all of the connections for the power bus and the accessory bus here on the layout. And I used them on the earlier layout as well. And again, it's www.powerwerx.com, powerwerx.com, and these are Anderson power poles. And I'm not sure if anybody else sells them or if PowerWorks has basically a monopoly on the sale of these things. I'm not sure, but just look them up. You can get them and order them, and they come. You can get a set of like 10, 25, etc. So they work out fairly well. They're fairly easy to put together, and a lot of modular layout builders and organizations have switched to these Anderson power poles. So let me get these in here. Okay, I've got all the holes drilled, so now let's feed the power bus through. Okay, right through there. And let me go over the other side and grab it, and we'll feed it through this one. Okay, and I'm just going to leave a little bit extending out each end. And in the future, I will cut this piece off, this long extension on this end, and install it on the second module the same way. Okay, so there we have the installation of the DCC power bus. Not a big issue. Next, let's take a look at attaching the feeders to the power bus. Now, for my connections here to the power bus, I'm going to be using these 3M suitcase connectors. And they're referred to as a suitcase connector because they have this little clip here that closes like a suitcase. And I'll show you how those work later. Okay, but the one I'm using is a 3M number 905 insulation displacement connector. And I got these on Amazon, and you can find them at a bunch of other suppliers that sell electronic supplies. Now, the thing about these is they are a great connector. What they do is, the way they work, they have a little metal blade in here, and it goes down cuts through the insulation. That's why it's called insulation displacement. So it cuts through the insulation on the outside of the wire and then bites the outside of the wire slightly to make an electrical connection. And it has room for two wires, what's called a run wire and a tap wire. And the DCC power bus is your run wire. The feeders are your tap wires. Now, the important thing to remember about these is they are made for certain sizes of wire. In the case of the 905, they can be used with either solid wire or stranded wire. And the run wire can be 18 to 14 gauge. The tap wire can be 22 to 18 gauge. And that's the common sizes that we use for DCC. I'm using 14 gauge wire here for the power bus, and I'm using 20 gauge feeders. And that's what's important, because there will be a lot of people that will say these things are garbage, they don't work, they fail, all kinds of things like that. And the reason for that is those people don't read the instructions and don't follow them, because these things are made for certain sizes of wire, and you have to install them accordingly. If you use them with the wrong size wire, they will fail. If you install them improperly, they will fail. So, follow the instructions, do it right, and you'll be fine. And I like using these because you don't have to do any soldering. Okay? Now, what do I use? This is a vice grip channel lock pair of pliers. It gives you a nice square clamp down on the suitcase connectors. And when you're going to install these, that's important because you're going to go like this. And you're going to pinch, you're going to close down with the pliers. And you want that to be a perfect straight insertion there. And to get that, you have to use a pair of pliers that are going to work like that. Now, they make special pliers for that. I've been using pliers like this for years, and they work fine for it. But you do have to make sure that you get them square, because if you don't get a good square crimp on them, it's not going to work. It will fail on you, just like the critics say. Now, let me show you how this works. And for that, I'm going to bring you in here real close. Okay, I'm going to begin right here with this pair of feeders. And this is our power bus right here. And remember, I'm going to be using the red feeder wire and connecting it to the red copper wire here in the power bus. And then the silver wire, which is just tinned copper, I'll be attaching the black wire to it. So we're going to go right there, and then I'm going to make a slit right here between the two conductors. And you'll see why you have to do that here in just a second. Okay. That should be enough. Okay. So now I'll pull those apart just far enough so I can make that connection. And then I'm going to take my suitcase connector and I'm going to open it up just a little bit so I can get these wires in there. And then I'm going to slide it over the red wire, like that. And that's all there is to making that slide-on connection there. Then you'll see, if you look at these, there's an opened end and a closed end. The red wire goes into the open end here, just like that. Then I'm going to take my pliers and, holding this feeder in place, I'm going to slide my pliers in there and I'm going to crimp down on this, closing those jaws tightly until this suitcase lid closes and clips. And that's all there is to it. That's how you make a solderless connection using these suitcase connectors. And let me put the black wire in place now. Okay, so very simple, just the other side is all you need to do. Slide it in there like so. Close it a little bit. And this is the closed end, so the black wire is going to go in down here, like that. Okay. Then take the pliers, once again get a good square placement, and then squeeze it as tight as you can to get that wire to cut in, to get that blade to cut in there, and then clip it. And that's it. And these are now very, very tight. So that's all you have to do to get a good solid connection with the Suitcase connectors. And those things will last you until you tear your layout apart or pull these apart. Now, one thing, if you have a mistake and it doesn't go on correctly, you have to take this and throw it away and use a new one, because once you have messed up on this, it will not be, you cannot use them again. So that's the one thing, get it right the first time, or be prepared to toss one and use a new one. Do not try to reuse ones that you've made a bad connection on or bad crimp on. Okay, I'm going to go ahead and finish doing the rest of these, and then we'll be ready for the next step in the process. Okay, so I have the IP Digital switch machine ready to be installed. I've replaced the original throw rod with one that is 0.032 inches. And these are available from K&S metals and wire. I ordered these from Ace Hardware. You can also find them at most hobby shops. Hobbytown usually has these, a display of them. You can get pieces that are 3 feet long. You can get pieces that are 1 foot long, depending on where you order them or if you pick them up at the store. The reason I do that is because I've got a 1/2 inch of plywood and a 1/2 inch of foam sub-road bed, and then almost 1/4 inch of foam road bed on top of that, plus the thickness of the ties to go through. So that's much longer distance than what you normally expect with what comes with these or with a tortoise. So that's why I do that. I've been doing it for some time, and it works fairly well and reliable and gives you a little bit stronger throw. Okay, so what I have to do now is these come with these little adhesive pads that sit on the bottom of the switch machine. And then you peel off this paper cover and slide it in and start probing with this throw bar, this wire here. And that will get you, and eventually you'll be able to poke it up through the hole in the throw rod between the 2 point rails. And once you got that done, then I just lower that into position so that the adhesive backing here holds it in place until I can then install screws. And what they say is that the adhesive is strong enough to hold it, and that they recommend installing it with the screws, leaving it on there for a week or so for the adhesive to get a really strong bond, and then take the screws out. And it'll be quieter because you don't have those screws going into the wood and amplifying it. So let me show you. This is how I go about doing it. I just insert the throw rod or throw bar in there and start working it up in here until it comes out the other side. Okay, so finally I got it in place, and I press the adhesive pad in there, and that's staying. One thing you can do if you need extra time is take a hemostat and clip it to the wire where it comes through the throw bar on the points. And that'll hold it while you get the switch machine firmly pressed into place. And now while I've got it in place, I've taken my power cab and connected it to the switch machine. And this is right here. You can see the wire coming out of the points. And let's see if it's going to throw. Okay, it's good and tight up against that rail. Throw it back the other way. Good and tight there. Throw it back again. Okay, good and tight. Okay, so that is the first of 11 total that I have to install, and we'll get those done before next week. And at that point, we should be able to connect the power cab to the power bus and see if a locomotive runs all the way across the module. Okay, and so the last thing I need to do is install the screws here. So we'll put them into place like so, and use my power screwdriver from Black & Decker to drive them home. These are pretty sharp and pretty good screws, so I'm not drilling any pilot holes for them. I'm just going to drive them straight in. And they go right in without much problem at all. The hard part is down here underneath, and for that I'm going to use a pair of tweezers to hold them while I get them started. Okay, that's in there good and tight now. So that's it for number 1, 10 more to go. Okay, there's one last thing I want to do here now that I've got the switch machine installed, and that's prepare the frog feeder here. And I've just stripped off 10 millimeters of wire. And that's so I can insert that down into one of these little connector slots. The way these were designed, this connector right here, the third one over, there's DCC in here, DCC in here, and then this connector right here. And that's where the frog connection is. And what that does is, it passes the correct polarity from either one of these DCC inputs to your frog. Just that simple to install it. It's a quick grip, tight grip connector. You just push it in there and it grips it and you're done. Very quick and easy wiring. And when we get the accessory bus installed, I'm going to be powering these switch machines using the accessory bus itself. So these will not be drawing power off of the main power bus, but instead the accessory power bus. And we'll talk more about that when we get to power management and installing the DCC system here. Okay, so that's it for today. I'm going to keep working on installing switch machines and making connections to the power bus. I will also have the accessory bus installed by next week as well. So we'll be able to power everything up and make a temporary connection using the power cab to test the wiring out, make sure that there's no short circuits, anything like that. So come on back next week for that video, and in the meantime, have a great week, have a great weekend. Bye now.